So our mass here is 54. Our velocity is 15. Do we need to convert either of those, or are they in the correct units? Correct units. Okay, so we're going to take 54 times 15. And we get what? 810. What's our units that go with this? With momentum? Kilograms times meters per second. And we're missing one major thing with this, with our answer. Since it's a velocity or a vector quantity, we have to have what? Direction. Okay? So since we know that our momentum has to be in the same direction as our velocity, we need to label our answer left. Okay, so our momentum is 810 kilograms times meters per second left. Okay, if we were to indicate a coordinate system at the top of the problem or at the beginning of the problem, saying that left is positive and right is negative, then we could just leave it as our 810 because that's a positive answer. Okay, but we have to indicate that if that's what you're going to do. If you don't give me a coordinate system and you don't give me a direction at the end, I assume that we don't know what direction it's going, and then that's wrong. Okay, so we've got to give me a direction, whether it's in a coordinate system or whether it's labeling it at the end. Does that make sense? Okay. All right. All right. This is a 20 kilogram ball hits the floor with a speed of 13.2 meters per second. If the speed of the ball coming off the floor is 11.5 meters per second, what was the ball's change in momentum? Right, if we're solving for change in momentum, what does that mean we are solving for? To be a change in needs to have what? Yeah, we're solving for delta P. All right, so delta P equals mass times delta V. All right, so what's happening in this motion is that this ball hits the floor and then it bounces right back up. Okay, what is it about those two velocities that we need to make sure and distinguish?
Which one's the final and initial?
Okay, yep, which one's the final, which one's initial? What about direction-wise? One of them's going up, one of them's going down. So one of our velocities has to be negative. Okay, so we'll probably indicate that up is the positive direction, down is the negative direction. That way we're consistent with what we've always done. So that means our mass is 20. That won't change. Our initial velocity is this number right here, this 13.2. Is it going to be positive or negative? It's going to be negative because it's going down. It's hitting the floor. Okay, when it bounces off the floor and comes back up, it's moving at a speed of 11.5 meters per second. So our velocity final will be a positive 11.5. All right, so now if I plug this in, I'm solving for delta P. I'm going to take my mass times my final velocity, which is 11.5, minus my initial velocity, which is 13.2. When I add, or when I subtract a negative, that means I really add them together. So I'm going to take 11.5 plus 13.2 and multiply that whole number by 20. Okay, is it positive or negative? Positive. Okay. And our units should be? Good. Extra work, and I want you to see if you could figure out where that extra work has to be done. Okay, so this says a 30 kilogram object is dropped from a height of 9.5 meters. What's the object's momentum after falling 5 meters? What does it not tell us here? It does not tell us the velocity. So that means we have to solve for velocity. So right now, we know that this object starts up here at, oops, You didn't see that. Starts up here at 9.5 meters. It falls a distance of 5 meters, and it ends up at 4.5. So now this object's down at the bottom. We need to find its velocity during that time. All right, so now we're going to solve for the velocity of this dropped object. How do we go about solving for velocity of a dropped object? We're going to have to look back at our kinematics equations. Okay, so you might want to pull those out if you don't have those. All right, so I started kind of compiling my list here on the side. We know our mass. We know our initial height was 9.5 meters. We know it fell 5 meters down to a height of 4.5 meters, so that's my y final. What's my initial velocity of a dropped object? 0. Okay, so my velocity initial is going to be 0. My velocity final is going to be what we're solving for. Okay. So take a look at your kinematics equations. See what you can do without having time. What equation can we use to solve for velocity final if we don't have time? Yeah. So Vf squared equals Vi squared plus 2a y final minus y initial. Okay, we can use this equation when we don't have time and we want to solve for final velocity. We know the V sub I squared is going to be 0 because it's starting from a drop. Okay, someone's dropping it, so its initial velocity is going to be 0. What's the acceleration when we're looking at vertical objects? Yeah, good, negative 9.8. And we'll take our final, which is 4.5, minus 9, which was our, 9.5, which was our initial. Okay, now if I want to solve for velocity there, I need to square root that. So my velocity final is going to be what? 9 point what?
I got 98. I got 98 and then the square root of that. 9.8.
The square root was 9.89. Or no.
Yeah, you.
Oh, but you got 98 right there?
Mm-hmm. Yeah.
Oh, that I know why. Okay, yep. So when we square root that, we'll get a 9.9 for our velocity. Okay, great. So now we have our velocity and we have our mass. So to solve for momentum, we can just take our mass times velocity. So 30 times 9.9. 297. Okay. Let's think about this velocity right here. Is it going up or going down? Down, so this should be negative, which means our momentum should be negative as well because it will be going down. So kilograms times meters per second. And the negative here tells us the direction. Okay, it tells us that it's going down. We're going to look at collisions now, two things colliding. We're looking at momentum overall. Momentum is always conserved. Kinetic energy is not always necessarily conserved, but momentum is. Okay, so when two things collide, whether it's elastic or inelastic, the momentum is conserved. Okay, so momentum before the collision will always equal momentum after the collision. Doesn't matter the mass or the velocity of the object. This equation right here is for elastic collisions. Okay, so these are things that hit and rebound off each other or bounce back or whatever, but these are elastic collisions. All right, and what it's saying here is that the mass of the first object times the velocity of the first object, so momentum of the first object here, plus the momentum of the second object will equal the momentum of the first object after the collision. That's what this prime means right here. It's a little apostrophe. It's called a prime. So this means after the collision, and this means the momentum of the second object after the collision. Okay? So that's what that prime means, that little apostrophe. It means after the collision. Problem. Okay, we'll practice an elastic collision problem. Find the recoil velocity of a 5 kilogram rifle that shoots a 0.05 kilogram bullet with a speed of 120 meters per second. I want to make the distinction here that both of these objects will start at rest. Okay, so you know what the recoil is of a gun? Okay, after you shoot a gun, it kind of kicks back at you a little bit. We're trying to find that speed of that kickback. Okay, so when it's fired, the moment it's fired, it kicks back at you. We want to find that little velocity right there. Okay, but before that, before our collision, it starts at rest. So both velocities are at rest at the beginning here. So we'll just go ahead and say that our rifle is going to be our first object, just because it's listed first. It doesn't make a difference, and it doesn't make any difference at all if you choose the bullet to be the first object. It doesn't matter what order they go in. All right. So our mass 1 is 5 kilograms. Our velocity 1 is 0. Mass 2 is 0.05. V sub 2 equals 120. And that's going to be V sub 2 prime, right? Because that's after it's fired. So V sub 2 prime. So let's go ahead and start plugging things in. If we take our we'll go ahead and just use this equation, M1V1 plus M2V2 equals M1V1 prime plus M2V2 prime. Okay, that's the equation that we're using. So let's go ahead and plug things in. We take 5. We know our initial velocity is 0. We know the initial velocity of our bullet is also 0. So that whole left side of the equation's momentum is 0. We're trying to solve for V1 prime. We're trying to solve for the velocity of the rifle after it's been fired. And we know the velocity of the bullet after it's been fired is 120 meters per second. Okay, so both of these equal 0 right here. So this whole left side of the equation is 0. 5 times V sub 1 prime plus 0.05 times 120, which I believe is 6. So then to solve for our V sub 1 prime, we're going to subtract the 6 over. And then we'll have negative 6 equals 5 times V sub 1 prime. To solve for V sub 1, we're just going to divide by 5. Divide by 5. And we get what? Negative 1.2. What's our units then for velocity? Meters per second. Velocity is just meters per second.
So velocity 1 is like how fast, what's that explain? Like how fast?
Right here or this right here?
Like 5, that's how much the rifle weighs, the 5 kilograms, and then
Right here?
0.5 is how the bullet, yeah.
Uh-huh. This right here is showing us that initially this rifle is at rest. Okay, before this thing is fired, everything's at rest. After it's fired is when we look at the velocity. Okay? So what this is saying is that this negative 1.2, it's telling us it's going in the opposite direction of the bullet, which makes sense because we know it's going to go backward, the bullet's going to go forward. All right? Okay, a 45 kilogram object's moving to the right at a 5 meters per second. it collides with an object that's 60 kilograms moving at 10 meters per second to the left. If after the collision the 45 kilogram object moves left at 6.3 meters per second, what's the velocity of the 60 kilogram object? Okay, I know that seems like a lot of words. It's not that difficult. Before we can really get started solving the math, and I'll give you time to get it written down and everything, before we can really get started with the math, we've got to choose a coordinate system. Is to the left going to be positive or to the right positive?
Right.
Yeah, that's what I would choose. To the right to be positive, to the left to be negative. Okay, so that will give you a clue as to what your velocities need to be. All right, so I'm going to just go ahead and start plugging things in here. We'll say mass 1 is the 45 kilogram object. Velocity initial of this 45 kilogram object is to the right at 5 meters per second, so that's a positive 5. Mass 2 is going to be our 60 kilogram object. And our V sub 2 is moving left at 10 meters, which means it should be what?
Negative.
Yep, good, negative 10. And we know one other thing that we can be plugged in here. Okay, what variable will this be plugged in for? V sub 1 prime. Good, very good. V1 prime is going to be what? Negative 6.3. Perfect, because it's going to the left. Very good. So I'll go ahead and start plugging things in here. We'll take 45 times 5. Okay, that's M1 times V1 plus 60 times negative 10. Okay, which is M2 times V2. All right, that's going to equal our 45 times negative 6.3, which is M1 V1 prime, plus 60 times V2 prime. All right, which is M2 V2 prime. All right, so what did we get for our V2 prime?
Negative
1.525, so 1.53 meters per second. And what's the negative tell us here? Yeah, it's going left. It tells us it's going left. Very good. All right, what questions do you have about elastic collisions? Then elastic. Okay, we're going to look at an issue of two trains. Okay, one train is sitting stationary. The second train comes up and meets it, and they start to move together. Okay, so they'll meet up, connect, and then keep moving on with their path or whatever. Okay, their route. Okay, so we're going to start with a train that's stationary. Okay, here's our little blue train. That's our first train. And then, ooh, ah.
What's gonna happen?
Ooh, okay. They're going to come and meet. Okay, that's that collision. This red train came in with a velocity of 24 meters per second. Okay, so our blue train was initially at rest. Our red train came in at 24 meters per second, and each train has a mass of 10,000 kilograms. Okay? So here's our before collision. What's happening? Here's our after collision. They're connected, and they're going to be moving with a velocity to the right. Okay, since that's what this one was moving with, first of all, they're both going to be moving to the right. All right? So we want to try and find the velocity of these trains after the collision. Okay, and in an inelastic collision, after the collision, the masses become connected and become one unit. Okay, so the equation that we're going to use for finding inelastic collisions is this right here. This is the same. Momentum of the first object plus momentum of the second object will equal both the masses added together with one single velocity. Okay, since they will become one unit, they will have one velocity and now one mass. All right, so we're going to go ahead and take our 10,000 kilograms for our blue train times 0 since it's sitting stationary. Our 10,000 for our red train times 24 since that was its initial velocity. We'll take both of our trains added together times our v prime, which is what we're going to be solving for. All right, so the left side of our equation here will give us 240,000, and the right side will give us 20,000 times v prime. All right, so we want to divide that over, and we're going to get our v prime to equal 12 meters per second. How does this velocity compare to the initial velocity of our first train, of our red train? It's half, okay? When we have objects of two equal mass that collide in an inelastic collision, our resultant velocity will be half of the first, okay? As long as one of them was resting, okay? It's going to be easiest for you to just plug it in every time, but if you can see that relationship, it'll kind of help you check your answer to make sure it makes sense. All right? Try this one on your own. A 35 kilogram bullet is fired at 200 meters per second. If this hits and sticks to its target, that begins in stationary, begins at 0, or begins with no velocity. If the mass of the target weighs 45 kilograms, what's the velocity of the target after impact? So here we need to make sure what's happening is that this bullet is fired, it's hitting the target and just barely moving those two together. So the bullet and the target stick together and they'll move just a tiny little bit back. We want to find that velocity of that system. All right, so we get 0.155 meters per second in the direction of the bullet.